Hello, students, and welcome back. This chapter begins our discussion of atoms and elements. We'll learn what atoms and elements are, we'll learn about the periodic table, and we'll learn about some periodic trends. In other words, some repeating patterns of elements. Let's get started. Atoms are the basic building blocks of everything, all matter that we see around us. By understanding the properties of individual atoms and the repeating trends from the periodic table, we can learn how atoms go together to form molecules. And molecules make up everything we see around us, and even biological systems are made of molecules and atoms. You can think of atoms like Lego pieces that kind of stick together to form larger molecules. Many people use chemical knowledge in their jobs, like farmers have to understand a little bit about chemicals and how that applies to their crops or their animals. So they need to understand pesticides and herbicides and drugs so that they can help understand the best course of action when a problem arises. Elements are pure substances from which all other things are built. They can't be broken down into simpler substances. And if you purchase the text, you can find a list of the elements in the front cover of the text in the form of the periodic table. And we'll take a look at that in just a minute, or at least a periodic table. Given the name of an element, we want to learn to write its correct symbol, and from the symbol, write the correct name. So let's go ahead and take a look at the periodic table. Here we have a periodic table such as you might find on the front cover of your book. Notice there are one or two letter symbols identifying each element. We use these as abbreviations for the elements. We're going to learn more about the periodic table as we move through this section of this chapter. But just as a quick overview, what do we notice? We notice that there are rows on the periodic table and there are columns on the periodic table. The columns indicate repeating trends of different elements, so repeating chemical behavior. The elements we see listed have the abbreviation, which is their chemical symbol, such as an H for hydrogen, a Be for beryllium, so they can be one element, they can be one letter or two letter names. And then in this periodic table, the name is listed under the element. Now, not all periodic tables have the name under the element, some just have the symbol for simplicity. You'll also notice a number under the element. This is the average atomic mass for that element, and we're going to learn to calculate that later in this chapter. Notice that there are only 118 elements on this periodic table. Most of the elements that we have around us every day are not these heavier elements at the bottom. The elements at the bottom are generally radioactive elements that may not even be found in nature and may exist only briefly when they're synthesized by scientists. Most of the elements that are found in living organisms, in fact, are up here at the top right of the periodic table. So we have, and also hydrogen. So we have hydrogen, which can be connected to some elements like carbon. We can also find hydrogen connected to nitrogen. So hydrogen, nitrogen, carbon, oxygen, sulfur, phosphorus, these are all found in the human body or in living systems. And also we have some metal ions that are found in living systems as well. We have sodium, we have calcium, we have potassium. Sodium and calcium are important in ion channels in proteins that help to uh, keep a gradient, an electrochemical gradient across the cell membrane. So each of the elements found in living systems serves a purpose, and those elements have the bonding patterns that are characteristic for each of the elements. And so these bonding patterns tend to repeat themselves in columns on the periodic table. Dmitri Mendeleev was the first chemist to notice these repeating patterns. In fact, he noticed that these patterns tend to come in octaves, much as we note in music, and he made the comparison between the octaves in music and octaves on the periodic table, and we know that those octaves tend to give us a full valence shell uh, from the rows on the periodic table. And through filling up a shell with electrons, we can have a filled and stable element, which leads to stable chemical bonds. Here are some examples of some elements that can be found on the periodic table, and the symbol for those elements and the reason for the name for each of these elements. For example, we have uranium, which has the symbol U, which is given from the planet taken from the planet Uranus. We have titanium, which has the symbol Ti. Now that's supposed to be a Ti, not a Tl. Tl is thallium, and it came from the Greek mythological name Titans. We have chlorine, which is Cl, which comes from the name chloros, which is a Greek name for greenish yellow. Remember, a lot of these elements have been known for a long time. We have iodine, which is actually a solid that sublimes at room temperature and forms a purple gas. And so the symbol for iodine is I, and that comes from the name iotis, which is a Greek term for violet. We have magnesium, which has the symbol Mg, and this comes from magnesia. Think milk of magnesia, and that actually has magnesium in it. We have tennessine, which was actually named after the state of Tennessee because it was only discovered in 2010, or at least it was synthesized in 2010. This element is not a naturally occurring element. We have curium, which is named after the Curies, Marie and Pierre Curie, which obviously you've probably heard of, which are famous scientists. And we have copernicium, which is named after Copernicus and has the symbol Cn. Again, chemical symbols represent the names of the elements with one or two letters to give us an abbreviation for each of the elements on the periodic table. We can have one letter symbols. We have C for carbon, N for nitrogen, F for fluorine, O for oxygen. Or we can have two letter symbols. We have CO for cobalt, Ca for calcium. You can see that we used C for carbon, so we needed two letters to identify calcium and cobalt. We have Al for aluminum, and we have Mg for magnesium, and so forth. A lot of elements' symbols come from their Latin names. For example, the Latin name for gold was aurum, and the symbol is Au. And for iron was ferrum, and it's Fe. So ferrous means made of iron. Okay, lead comes from plumbum, which stands for plumbing because plumbing used to be made of lead when it wasn't known to be dangerous like we know now. And the symbol is Pb, and so forth. So, for example, silver is argentum, Ag, potassium, kalium, K. And so a lot of the elements do actually come from Greek or Latin words. So you can see a lot of the common elements names and symbols given here in this chart. Here are some pictures of a couple of the elements. We have gold, aurum or Au, and we have silver, argentum, which is Ag. Let's see if we can write the correct chemical symbols for some elements. Iodine, iron, magnesium, zinc, and nitrogen. If you forget, you can always reference your periodic table. Iodine is I, iron is Fe, magnesium is Mg, zinc is Zn, and nitrogen is N. Now let's give the names of the elements from these symbols: P, Al, Mn, H, and K. P stands for phosphorus, Al aluminum, Mn manganese, H hydrogen, K potassium. In the next section, we'll look at some periodic trends from the periodic table.